What I have here is a quadratic equation that's in standard form, and I want to convert it to vertex form. Once we're done, we'll look at the advantages of vertex form and what it can be used for. So since we have the standard form here, I'm going to also write y equals a times x minus h squared plus k. And this is the basic form that the vertex form would take. And in this case, our a is a 1, so we're not going to do anything with that. But what I want to do is I want to talk about this part over here. And in order to change to vertex form, I need to do something called completing the square. So first I rewrite on the next line the ax squared plus bx, and I expand it so that I can complete the square. And in order to complete the square, I cut this number in half too, and I square it. I'm just going to put plus 2 squared here. It's 4, but I'm just going to put plus 2 squared. And since I added 4 here, I have to also subtract 4 on this side over here. Now, this part in here simplifies to be a perfect square, which is x plus 2. And if you were to use FOIL for x plus 2 times x plus 2, you would get this. And then over here, I had plus 5 minus 4, so I have plus 1. So we're now in vertex form, and now what we want to talk about is this part that's in here to give us the x coordinate for the minimum value of this function. Well, the minimum value of this function, since I'm squaring it and this is going to be positive, x has to be greater than or equal to 0. So what number would I put in for x that would make this 0? And the answer is that x is minus 2. So if I put a minus 2 in there, this part would be 0, and then it would give me y equals 1. Well, that's our minimum value point. Here in Desmos, which is a graphing calculator, I've put the equation in, and this is the graph. And if I look at this minimum point over here, it shows it to be minus 2 comma 1. And it's a minimum value. One quick way to check your answer to find the vertex is minus b over 2a. And this is from the original over here. So negative b is minus 4 divided by 2 times 1 gives us minus 4 over 2, or minus 2. And we see that our answer is correct. In order to go from vertex form back to standard form, I would expand this and multiply the two binomials. Then I would multiply using FOIL. Then I would combine like terms. Plus 4 and minus 4 will add up to 0. So you get x squared plus 4x plus 5, and we see that it works. So here we have a quadratic where the leading coefficient is not a 1. And when we're changing to vertex form, that does change something. Not much, but you do have to pay attention to it. So I have y equals, and I'm going to group these two together. I'm going to factor out the 4. And then what I have inside is x squared plus 2x. And then when I complete the square, I want to take half of this, and then this is going to be plus 1 squared. This I'm bringing the 12 down, and since I added 1 squared, which is 1 here, now keep in mind that this is multiplied by 4, so when I get the 1 squared here, it's 1 times 4. I've added 4 here, so I have to subtract 4 here. So my perfect square binomial is x plus 1 squared, and then I'm adding 12 and subtracting the 4, and simplifying for the next line. So now that we're in vertex form, it's easy to see where the vertex is. Looking at this part that's in here, the smallest value x can be is going to be minus 1. So the resulting y value, if I put in a minus 1, the x falls out, and then the y would be 8. So the vertex is minus 1 comma 8. And to test this, the minus b over 2a from the original standard form. So negative b is minus 8, and 2 times a is 8. So I get minus 1, and that confirms that my vertex is correct. In this example, we again see that a is not 1, it's greater than 1. And then what's different is we have a minus sign here for the second term. So we're going to change to vertex form. First thing I'm going to do is I'm going to group these two together. So I'm going to pull out a 5. And then what's going to remain inside is x squared minus 2x. So for completing the square, I take half of 2, half of minus 2, which is minus 1, square it. I get plus 1. I'll put plus 1 squared here. And since I'm adding, and this is 5 times 1, since I'm adding 5, I have to also subtract 5 from this side so that this whole thing maintains the same value. On the next line, we have 5 times the perfect square of x minus 1 times itself, squared, plus 1. So now the vertex is what's going to make this value 0. So this would be a positive 1 this time. And when I plug in a positive 1, this is 0, falls out, y is 1. So my vertex is at 1, 1, and we'll again test using the minus b over 2a from the standard form. Minus b is 10, and 2 times a is 5, that's 10, so it's 1. So this is the correct answer. Here for these last two, I would like for you to try to change this standard form into vertex form and change this vertex form back into standard form. So pause the video, try it, and we'll see what you get. Well, for the first one here, we're going to group these two together and pull out the 4. What I get inside is x squared minus 3x, leave a space for completing the square, plus 10. And then I take half of 3. This is an odd case for completing the square. And half of this is 1.5, 1.5 squared. We'll just leave it as is on that side, but 1.5 squared is 2.25 times 4 is 9. So I subtract 9 from the other side. Just as a reminder, I didn't only add 1.5 squared, which is 2.25 here. It's 4 times 2.25. Now simplifying for the first line, I bring down the 4. This is going to be x minus, this is a negative sign, so x minus 1.5 squared, and 10 minus 9 is 1. So the vertex is going to be at 1.5, 1, using the minus b divided by 2a method from the standard form. Negative b is positive 12, and 2 times a is 8. And this simplifies to be 1.5. Now to change the vertex form back into standard form, I have y equals, and now I do x plus 3, 2 times x plus 3 times x plus 3 plus 3. And now I'm going to multiply. I'll keep the 2 outside, so I have x squared plus 6x plus 9 plus 3. And now I'll distribute the 2, so I have 2x squared plus 12x plus 18 plus 3. And then I simply combine like terms here, so I get 2x squared plus 12x plus 21.